Hello, everybody. Welcome to Chapter 7, Section 2, the division property of exponents. Today we're going to use those same properties or different properties of exponents as Section 7.1, and we're going to simplify expressions that include division or quotients or fractions. And then we got to talk about zeros and negative exponents. So let's start off with the quotient of powers property. Again, I am going to do the example first, and then we're going to talk about that shortcut because no shortcut is a shortcut if it doesn't work or you don't understand it. So the quotient of powers. First one, you would see a problem that looks like x to the 7 over x to the 2. Quotient always means divide, right? So we've got ourselves a division property, and we know that division is the same as a fraction. So again, if you think back to lesson 7.1 where we talked about if it's simplified, it only has each base one time. Well, we've got x's all over the place. So we need to simplify this. So I'm going to do what I did in the last section, where I'm going to write this out, and I'm going to ask you to write them all out. So after 7.2, don't quote me, but yeah, after 7.2, I'm going to say you don't have to write them out the long way anymore and check them with shortcuts, but I want you to understand what's happening. So if I've got an x to the 7th in a numerator, repeat multiplication, I got 7 of those little guys up there in the numerator. 1, 2, 3, 4, 5, 6, 7. I've got 2 x's down here in the denominator. Think back to fractions. As a teacher, as a math teacher, am I going to be satisfied if a fraction is not simplified? So, just like, I think I used the example 2/10, just like we could say that that's 2 times 1, and we could say that 10 is 2 times 5. Why don't I write that where you can see it a little bit better? 2/10. Notice how I found a 2 that goes into both of those. So really what we did is we're canceling out or dividing both sides by a set of 2's, and I'm left with a 1/5 for my simplest form. Well, we can do the same thing with variables. So if I'm going to simplify this pair of x's with this pair of x's, I can also take this pair of x's with this pair of x's. I can only simplify a numerator and a denominator pair. They have to have a match to them. There are no pairs of x's left because there's none left in the denominator. So for my answer, I'm going to write out x to a power. I've only got one base. And notice I have got 1, 2, 3, 4, 5 x's left in the numerator, no x's left in the denominator. If I had x's left in the denominator, I'd have to put 1 over to make sure I show that they're in the denominator. So x to the 5th. If we're thinking shortcut, how did I get from an x to the 7th over x squared to an x to the 5th power? The shortcut is to keep the base, the x stays the same, and subtract the exponent. 7 minus 2 gives me that 5. Seems pretty simple, right? If you can see it, you understand why you're subtracting the exponents. Power of a quotient. In other words, I've got myself a fraction like, let's just do an x squared over 5 to the 2nd power. So I've got a quotient, x squared over 5. I've got a fraction division problem being raised to that 2nd power on the outside of the exponent. So I'm going to write it out the long way. I've got an x squared over 5 times an x squared over 5. This exponent 2 tells me how many times I have to write that inside parentheses out. And now I can go ahead and simplify. So this is like x times x. This is an x times x. So in my numerator, I can write x one time. What power will it be to? On the bottom, I'm just going to do my straight multiply denominator math. 5 times 5 gives me a 25. This one's a lot like that power of a product one that we did in section 7.1. You distribute the exponent to every term inside that parenthesis. So really what I did is I took x squared to the 2nd power, and I took 5 to the 2nd power. Again, that's the one that messes people up because somebody's going to tell me there's a 10 in the denominator because you added them instead because the shortcut is to add the exponents. So write it out so you can actually see that it's 5 times 5, which is a 25 for your denominator. Again, those two properties, power of a quotient and power of a product, are the ones that confuse people. So those ones, if that's the only one you need to write out in the end, then write that one out. Next property is zero exponent. This one happens to be my favorite. I'm going to do the shortcut first because there really isn't anything to know besides anything, I used an A, to the 0 power is always equal to 1. It's a trick problem. I'm going to throw it in there, people, and I'm going to see if you're paying attention. Anything to the 0 power is 1. So I could have a problem like x to the 0 y squared. And you're going to notice, it's trying to trick me. X to the 0 is 1. So I've just got 1y squared, or y to the second power, for my answer. Or I could do something like this, which is one of my favorites. 28 x to the 9th, y to the 10th, all to the 0 power. Well, if that whole thing is being raised to the 0 power, my final answer is 1. Don't be fooled by that. Anything that is raised to the 0 power is always 1. It's a good one. Keep that one in mind. I will try to trick you with that. Don't fall for my games. Negative exponents. This one I'm going to put the shortcut up first because really it's not a shortcut, it's the rule. So when you have a negative exponent, look at the examples that I put, 5 to the negative 2 or 1 over m to the negative 3. We've talked about reciprocals before. We talked about reciprocals when we did perpendicular slope. Remember, reciprocal is when you flip over your fraction. So for a negative exponent, you're going to use the reciprocal of the base. And once you do that, you get to make the exponent positive. One of our rules for simplifying in 7.1 was no negative exponents. So this is how we take care of it. Use the reciprocal of the base, and then you get to make the exponent positive. So if I've got 5 to the negative 2 power, my power is negative 2, my base is 5. So what's the reciprocal of 5? We all know if you want to make 5 into a fraction, you put it over 1. So I'll have 1 over 5. And then I get to make my positive or my negative 2 into a positive exponent. I just bring it right along with the 5. So then I've got 1 over 5 to the positive 2 power. So reciprocal of the base, and then make the exponent, bring it right along, but make it positive. And then, of course, I'm going to simplify that because I know that 5 squared is 5 times 5, or 25. So 1 over m to the negative 3. Well, this one is interesting. If I think of it this way, the base is 1 over m. Everybody knows that the reciprocal of 1 over m is m over 1, or just a plain old m. Then I get to change my negative 3 exponent to a positive 3 exponent. And since it's a variable, no simplifying. Sometimes I might give you a problem like x to the negative 2 over y to the negative 3. So when I talk about reciprocal, we'll talk about each piece separately, but sometimes people prefer to see it as flipping it to the other side of the fraction. If it's already in the numerator, put it in the denominator. If it's already in the denominator, move it to the numerator. So I usually do this. This x has a negative 2 on it, so I'm going to move that down to the bottom and make it a positive 2. It technically is the reciprocal, right? Because x over 1 is like 1 over x. I'm just taking each one of these pieces separately. And then this y to the negative 3, in order to make it a positive exponent, I'm going to move it to the other side of that fraction. So I'm really going to have a y up in the numerator because it started in the denominator. And then my negative 3 exponent becomes positive. So once you move it, think of that negative as going away. Once you move it, you can cancel that negative right out of there. So that x to the negative 2 over y to the negative 3 is really, in simplified form, y cubed over x squared. So use the reciprocal or flip it to the other side of the fraction. If you think of it that way, this 5 to the negative 2 problem that I started off with, really, if I flip it to the other side of the fraction, it would be 1 over 5, right? Because it would move from the numerator down to the denominator. All right, so those are all the rules or the shortcuts for this section. Let's do a few examples. See what I got for you. Let's start with an easy one. Number 1, I've got a to the 5b squared over ab cubed. So first of all, I got a's and b's everywhere. I'm only allowed to have an a to a power and a b to a power in my answer. I am allowed to, I know that this isn't a monomial because I've got a division in there, but I've got monomial over monomial. I am allowed to have fraction answers. So I might have, like that last example with the y cubed and the x squared, I might have a monomial in the denominator. So we identified monomials, but now we're going to simplify them, and we may have division because that's what we're talking about. So first of all, if I've got a to the 5b squared, you know how I always show work up here? When I show the work, that's what I'm expecting to see for your work. So I do it not because I love to do work, I do it because I want you to see what I'm looking for. So first of all, I wrote out the numerator and the denominator separately, and I did the repeat multiplication. A to the 5 means I had to write out 5 a's. B squared means I wrote out 2 b's, and then an a and a b cubed on the bottom. So think of it like a fraction. Think about it as simplifying. I can cross out pairs of a's and pairs of b's. I have to have matching ones, one from the numerator, one from the denominator. So it doesn't matter which one you take, first, last, in the middle, but I definitely have one pair of a's that I can cross out. B's, how many pairs do you see? I've got one with one, and it doesn't matter which one you take, you'll have the same number left. This b I'm going to cross out with this b. So once we do all of our crossing, there's no more pairs left. I'm ready to write my final answer. So how many a's do I have left? And where are they, the numerator, the denominator? I'm going to ask you that question a lot when we do these. So I've got 4 a's left, and that will be in the numerator, right? Right here. So a to the 4th power. How many b's do I have left, and where are they? I've got 1 b left in the denominator, so my b to the 1st, or just b, stays in the denominator. If we're thinking about the shortcut and just subtracting, I've got it, excuse me, an a to the 5th over a. So if, remember, plain old a in the denominator is a to the 1st. So if I subtract 5 minus 1 is 4. The bigger number is in the numerator, so that's where the a's are left. And I wanted to make sure I mentioned this because here when I've got a b squared and a b cubed, well, 3 minus 2 is 1. I've got 1b left. It's got to be left down in the denominator where the larger number is. So some people are going to say 3 minus 2 is negative 1. Well, that negative makes us flip it to the other side of the fraction, or the larger number tells you, the larger exponent tells you where the leftover b's will be. So I wanted to do a simple one with numbers as well. So I've got a negative 2k to the 2nd over a negative 6k to the 6th. If I'm going to write this out, don't forget I got 6 k's down here. So treat the numbers like a fraction. If you just have negative 2 over negative 6, and I'm going to tell you to simplify that, what are you going to simplify it to become? 1/3, right? 1/3. Negative divided by negative cancels out. So treat the numbers separately. Just do that on the side. Simplify it like an old-fashioned fraction, because I know you love fractions. Then deal with the variables. So how many sets of k's, how many pairs of k's do I have left? So how many k's do I have left, and where are they? So I've got k to the 4th, and it's going to be in the denominator, right? Because here's where all my k's are left. So my answer for this is going to be 1 over 3k to the 4th. 1 over, if there's nothing on the top, I have to put a 1 there. I have to have a placeholder to show that it's the numerator. So 1 over 3k to the 4th. My answer, this answer looks a little funny. It's not like centered, but it's right. It's just awkward looking. If I'm looking at the shortcut, fraction math with the numbers, just simplify. If I do with my 6 minus 2 for my exponents, that's 4, and the larger exponent's in the denominator, so I know it has to be k to the 4 in the denominator. Is this making sense to everybody? Write it out that long way. Sometimes this division stuff gets a bit mind-boggling, so write it out. It's not a big deal, and I'm going to ask you to anyway at the beginning. Now, Let's talk about this power of a quotient thing in number 3. So I've got a 2p over 3w cubed, and it's all to the second power. So second power out here tells me I've got 2p over 3w to the third 2 times. How are you liking monomials so far? If we're being technical, right, that's 2p over 3www and 2p over 3w. I think there's 3 w's there. So when we multiply, there's nothing we can cancel out on this particular problem. There's simpler ways to write it, though. I'm only allowed to have one p to a power in my answer. I'm only allowed to have one w as my base to a power. So let's do the math itself. So numerators, 2 times 2 is 4. P to the 1, 2 second power. On the bottom, 3 times 3 is 9. And then I've got 1, 2, 3, 4, 5, 6 w's. If you need to write out the 2 sets, like I did in blue, and then you can do that math. So remember, if we're thinking shortcut, let me go back to my original. I distribute this squared to everything. So 2 squared is 4. P to the second power. 3 squared is 9. W to the third squared, power to a power, you multiply those. Again, if you don't get the shortcuts or are confused or not confident, write it out, because that way you are confident that your answer is 4p squared over 9w to the 6. Number 4 is short and sweet. Do you see my trick in number 4? What's anything to the 0 power? Just a 1, right? That's the only thing that gets taken care of, though. There still are n's. So if I've got n times n on the top, n squared on the bottom, I'm going to cross out 2 pairs of n's. So I'm saying that my answer for number 4 is just 1n or n. Remember, I'm never going to write the 1, but I know that that m to the 0 became a 1. If I'm thinking shortcut here, n cubed over n squared. If I do 3 minus 2, I get 1. Larger exponents in the numerator, so really that's like n over 1 or just n. If it's in the numerator, you don't have to write a denominator unless you need one. Oh, we should talk about negative exponents. So 7 to the negative 2, this is a lot like that example 5 to the negative 2 that we just did. So what's a negative exponent tell you to do? I'm going to use the reciprocal of that base. What's the reciprocal of 7? Or, if you like, 7 over 1. So 1 over 7. Now, instead of having a negative exponent, since I use the reciprocal, I've got a positive exponent. So 1 over 7 to the second. And of course, we all know that that would be 1 over 49. Don't go to your calculator and don't tell me some kind of crazy fraction answer. I don't want to know that it's point something, 0.49, blah, blah, blah. Tell me that it's 1 over 49. All right, number 8 is very busy. First thing I look at, I've got negative exponents. Second thing I look at, I've got a fraction, 4 over 5, but that can't simplify. So I know I'm going to have a 4 over 5. Before I write this out the long way, I've got to take care of these negative exponents. So up here, I've got a d to the negative 2. So like that problem that we did with the y cubed and the x squared or whatever it was, in order to make that a d to the positive 2, where does it need to go? Down there, right? So I'm going to put that d to the positive 2 down there on the bottom. Cross it out if you like, that way you know you dealt with it. I've also got this c to the negative 4. I don't like a negative exponent. Nobody likes a negative exponent. So since it's in the denominator, in order to make it a c to the positive 4, where's it got to move? Am I doing anything with this c cubed right here? I'm just keeping it up there in the numerator. There's nothing that tells me to move it. This d to the 7th stays down here in the denominator. So it just so happens in this particular problem, I moved all my c's to the numerator, or they all ended up there, and all my d's ended up in the denominator. So if we're looking at c to the 4th times c to the 3rd, if we're looking at d squared And d to the 7th, well, 1, 2, 3. I'm going to have for my answer definitely a 4 and a 5. How many c's do I have and where will they be? I'm looking at c to the 7th up there in the numerator because I've got 1, 2, 3, 4, 5, 6, 7. Shortcut says add 4 plus 3 or get a 7. Denominator, I've got d's. So the question I always ask is how many d's do you have and where will they be? So I've got d to the 1, 2, 3, 4, 5, 6, 7, 8, 9. Shortcut says take 2 plus 7 and I get myself a 9. There's no other simplifying I can do. The fraction is in simplest form. Each base is written one time only. And I've got no negative exponents. So 4c to the 7th over 5d to the 9. Those negative exponents, you just got to take one little piece at a time. That's your only option. Let's talk about number 9. I think I'm going to skip number 10 and tell you to do that as a practice and make sure that you got that. So have me double check it if you want for number 10. Number 9, I've got d to the negative 3 times d to the 0 times d to the 6. Well, first of all, what do you notice first? I'm guessing you notice the d to the 0 first, right? What's d to the 0? Big old 1. Basically, that went away. I've got two bases that are d's. I'm not allowed to do that, so I need to simplify. My theory is let's make this into one giant fraction because then I can deal with that negative 3 exponent. So if I've got d to the negative 3, I always try to take care of negatives first because that is going to make life easier. So in order to take care of this d to the negative 3, I have to move that to the other side of the fraction or use the reciprocal. So I'm going to have d to the positive 3 down in the denominator. I've still got that 1 in the numerator, which I'm not even going to write. And I've still got that d to the 6th in the numerator, which I'm not even going to write. So now this seems like a pretty easy to simplify thing. I've got 6 d's in the numerator, 3 d's in the denominator. Start crossing them out in pairs. There's one pair, a second pair, a third pair. So how many d's do I have left and where will they be? 3 d's in the numerator, right? So d to the 3rd. I could put over 1, but I don't even need to. So that problem, while it looked a bit tricky, is d to the 3rd for the answer. If we went back to the original, the shortcut when you multiply is to add the exponents. So really, what I could do is negative 3 plus 0 plus 6 should get me a 3 for my new exponent, which I had. We're going to skip number 10, but we're going to go to number 11, because this is a good one. First of all, it says the area of a triangle. Well, first thing you need to know is that area of a triangle, that's a rectangle. Fix that. Area of a rectangle is 32x to the 4th, y to the 6th. Well, the area of a rectangle is base times height, or some of you learned it as length times width. It tells you to find the length of that rectangle. It gives you this side right here that is probably the width, right? Well, if we want to find the length, wouldn't we just divide the area? Actually, let's do it this way because you guys are good at this. If we want to find the length, that means I have to divide both sides by width. Remember when we did these simplifying, solving for variable? Well, if we solve for L, we're going to have to do the whole area divided by the width. So let's do that. The whole area is 32 x to the 4th, y to the 6th, divided by the width, which they tell us on the diagram is 8x cubed, y squared. So let's start off with fraction. If I gave you 32 over 8, I know that you would simplify that and you would know how. Whoops, ignore that answer that I just wrote there. 32 over 8 is the same as 4, right? Or 4 over 1. I'll put over 1 just in case. So now let's look at these x's. X to the 4th over x to the 3rd. So 1, 2, 3, 4. Down here, 1, 2, 3. How many pairs of x's are you going to be able to cross off? Or I like to ask, how many x's will you have left and where will they be? 1x up in the numerator. Or if you look at the shortcut, 4 minus 3 for your exponents is 1x to the first. For my y's, I've got 6 y's. 1, 2, 3 on the top, 2 down in the numerator. If I start crossing those guys off in pairs, how many y's will you have left and where will they be? So 4xy to the fourth over 1, or just 4xy to the fourth, is the length. Wasn't so bad. It looked a little bit messy, but it wasn't really that bad. And as you get better at these problems, you won't need all that extra sloppy work on the side because some of those shortcuts you're going to just start to know. So, believe it or not, it may or may not be Wednesday. So I got a classic joke for you, just for funsies. That's a, well, what sound does a nut make when it sneezes? Because you know nuts do make a lot of sneezing. Cashew. And then you, of course, say, bless you. Good one, right? So, to end the lesson, first of all, instead of telling me something about division and properties of exponents, write the answer to the classic joke. That's all you got to do. However, practice problem, I want you to simplify that problem. X cubed times x to the 0 times x to the negative 5. It's a lot like example number 9 if you need to refer back. Have a wonderful evening. We'll talk to you guys tomorrow.